Hey everybody. What we looked at in the first part of chapter 7 is we looked at a variety of care methods. We did see a couple string methods in code, but I want to show you a variety of string methods that apply to strings. And once you understand what they do to a character, pretty easy to understand what they do to a string. For example, if you say to uppercase to a string, it would convert any string to its uppercase, and to lowercase would be to its lowercase. But some new ones that we haven't dealt with yet. The reason we didn't have length with a character, they would all be 1. But in this case, length would count the length, or in other words, how many characters in the string. I'm going to show you an example of that in a second. And then I also want you to understand index of method. It determines whether a specific character occurs within a string, and it returns the position of that character. So, for example, in the word Lynchburg, is there the letter B, as in boy or Bob or Bella? So, is that in the word? And if so, which letter is it? But before you start counting, here's something that you should understand. Look at this third bullet. The first position when you save any string, the first letter is in the box called 0. We call that box the subscript of the string. I'll show you. I've got it all drawn out in a second. And the return value is -1 if it can't find the character you're looking for in the string. So I took a moment to kind of draw this out to make it a little bit easier. So in a program, I'm going to have int position to be 6, the integer. I have an unknown integer called s. I'm going to have an integer also called str length, probably for string length, right? And then here is the string. I'm going to assign a string called city to the word Lynchburg. Now, let me show you what happens when you do this. It creates this allocation in the memory of computer called RAM. And what it does is it has named this to be city. Oops, let me get that Y in there. Sometimes there we go, city. And it puts in, now I didn't do it perfect. What did I do wrong here? I did it uppercase. So I could use to upper. I'm going to have to add that to the program to switch it up. But as written, it would really be Lynchburg like this, right? Because it is case sensitive and it understands what that looks like. So it's really Lynchburg like this as is. So the L goes in what we call the index position or subscript of 0. Y is in 1, N is in 2, C is 3, H is 4, B is 5, U is 6, R is 7, G is 8. So if I were to ask you how many letters in Lynchburg, be careful not to say there's 8. When you start with 0, there's always one more than you think, right? Count it on your fingers. Lynchburg is 9 letters. So in this statement right here that I've just highlighted, when I say find the city.length method, it calls the length method. It goes and finds, there are 9 letters here. So string length is now going to be assigned to 9. And if I print that out later, string length is now 9. Let me also introduce something called substring. There are always 2 integers after substring. The first, the 0 right here, means what position do you want to start grabbing the characters from? So I'm going to start grabbing the characters starting at position 0, so I'm definitely going to grab that capital L. The second integer, when I use substring, means how many characters are you going to grab? I'm going to grab 3. So I'm going to grab the L, 1, the Y, 2, the N, 3. So what would S be assigned to in this one? It would be assigned to LYN. How about if I changed it? Let me copy this line again and do it again for you. So let's say I came over here, and now I'm going to change this statement to city substring, oh, I don't know, 5, and leave it at, we'll put it at, let's go to that 0, and we'll leave it at with 4. So what that would be, it would go to the 5th letter, 1, 2, 3, 4, 5. Oh, let me change it, I want 6. So it would go to the 6th letter, which is the B, one higher than you would expect, and grab those 4 letters, Berg. So this one would print Berg, all in capital letters. Hey, let's look down here. Another little piece of code. We have my string that represents, hello, planet Earth, you are a great planet, although 2020 has been rough on it, or at least on us. If I were to say my string dot index of, we haven't done that yet, what it would do is it's looking for what index, and by the way, these are the indexes or substrings down here. It's trying to find where does planet begin. Now, this is a little bit confusing because I've got planet here and I've got planet here. So first thing, it always finds the first one. So we are looking for this one. The question is, what would the index be? If I typed in HELLO space P, what would planet begin? Well, the H is 0. E1, L2, L3, O4. This blank space does count. That would be the 5th position, if you would, of the index. So P would start at 6. So the index of planet, of where it starts, is at the 6th position. By the way, it is easier sometimes to draw this out like I did with Lynchburg so that you don't make an error, because it's pretty easy to do. Another string method is called character at or char at method for strings. What this does is it finds, if you're looking for the letter N, what position is it at of the character that the method returns. So I'll show this to you in a second, but we also have ends with that finds what the last item is, starts with, what's the first letter of. So let me take you into the code because I always find coding makes more sense. I've just got a very little program here. I have a string called S that's assigned to strings are immutable. Now, hopefully you've done your reading this week or will. Immutable means that once you assign a string, it really doesn't change. Remember, we can check to see if it's equal to something else. But strings are immutable. They're assigned in memory permanently there. Well, until you turn off your computer, if they're in RAM. So here's what this statement does. This is that char at we were just looking at. So what this does is we are going to have a character result. So that means the result I'm about to get is a letter, a single letter. And char at always has to be assigned. We want to know what letter or what character is at the 8th position in this S. So do you see how we have S dot char at? So what's the 8th? But be careful. Don't forget the very first letter of strings are immutable. This was assigned to position 0. So S is in position 0, 1, 2, 3, 4, 5, 6. The blank space is 7. So the A is at position 8. And by the way, when you do assignments, you may want to draw this out like I did with this example. It's a lot easier to figure out sometimes because you can lose your count pretty easily. So it's going to print out that single character A when it goes single print out result. And I've already run it. Here's that letter A. How about if I switch this to 7 where that blank space is? Well, that gets a little tricky because it did just print out the blank space right here, but you didn't see it because it's a blank space. So sometimes that can be, you think you have no output, but you do. And if I want position 0, let's see what we get. I'll run it again. And position 0 should give me that capital S. So this is an easy way to find out what the first letter they input. And then you could check to see if that character is an uppercase letter or is a lowercase letter. This provides a lot of information. So next, one of the biggest terms that we have in Java is it's called to concatenate. Concatenation. So let me help you with what that simply means. This one's easy. It just means, can you add two strings together to make a single longer string? And we're using the plus sign, but in this case, it's not really adding anything. It's just connecting the two. So a string would now be equal to my age is space and whatever my age would be equal to. So let's now go look at a bigger program that puts lots of these together. So what I want to do next is I want to go into a program that has all of these methods all working together so you can kind of see the big picture here. So let's break it up into parts to make sure it all makes sense here and really put your thinking caps on. By the way, with these longer programs, you may just want to pause me, look through the code, and then as I explain it, it might make more sense to you if you've had a chance to read it through. So let's pick up now. We're going to have a string, just assigned to a string. We don't have any values yet. By the way, when we assign a string, it will assign it null, or what we call nothing, to it as of yet. But it does have a position in memory that it's waiting for a value. We have an integer called string length. We've kind of used this before, so that shouldn't be a shock. We're asking for some input here in a moment. We're going to say that the number of spaces is 0. And we do have a constant final integer position of 7. So that's what we've got so far. So now we're going to print out the words on the screen, enter a sentence. And we're going to ask the user to finally type in that sentence. And don't forget, everything they type in is a string. So now we might have a sentence that is some famous quote. Something like, so when it asks to enter a sentence, and I'm going to put in a string, I am going to type in down here, to err is human. To really mess something up, you need a computer. Isn't that the truth? After I hit enter, let's see what's happening to what we call a string. And I've assigned a string to a string up here. So let's look at line 13. str length is equal to a string dot length. What that's going to do is count up how many characters entirely, including spaces. So it says let me scroll up so I can see the whole thing. So down here it says the length of my sentence is 65. That means there were, including spaces and characters and letters, there are 65. That's more than I thought I had typed. So that would be important there. What else? So we've the length of your sentence is 65. And then we get into a for loop. And the for loop begins here, ends, goes from 16 to 20 is the program body. Let's look at the for loop. It begins where I is equal to 0. And it's going to keep on going until we get to 65. Remember, the string length is 65. So this loop's purpose is to go through something repeated 65 times. So what is it going to do 65 times? It's going to, let's look at line 17. It's going to look at a string, the sentence, to err is human. To really mess something up, you need a computer. And it's going to start at character 0. Char at looks at an individual position, and what ch will be is that letter. So when it's 0, it's going to be assigned to the capital letter T, and it's checking out, is this letter T, is it equal to, don't forget the two equal signs, to a space? Nope, it's not equal to a space. So the loop comes back up, and now I is equal to 1, position 1. It's going to go to care at 1, come down to my sentence. That'll be a letter O in 2. So is that a space? Nope. It's going to come around to I is now 2. Is now going to look at 2. Now look, so 0 and 1 were T and O. The space is number 2. And now we're saying, is that individual character equal to a space? This time it is. So num spaces were 0, but now by adding this increment, it adds 1. So we've found 1 space so far. So what lines 15 through 20 are doing is counting how many spaces are in my entire sentence. And if I look here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's see if it's right. Oh, look at this. The number of spaces in your sentence is 12, and it printed that right in line 21. So that's why you might use something like a care at. You say, well, how often do you need to know how many spaces? It's up to what you're trying to manipulate, and you're going to see in some of the programs you're going to write why you'd need some of these pieces. Now let's look at line 22. Let me make it a little bit bigger as we go down. So now we want to find the index of where the period is located. So it says if a string dot index of period is equal to -1. If you remember how index of works is if it never finds the period, it returns a -1. Now in our sentence, it's going to go down. Look, oh, there's a comma. No. Oh, there's a period. Since I did put a period at the end of the sentence, it's never true that it's -1. By the way, a string dot index of, it would actually find it at the position at the very end. Since I know there's 65 length, it actually finds the period, oh, this is a tricky question, at 66. So it's not true that it's equal to -1. -1 means it never found it. So it's going to pop down to line 24 and print out there was at least 1 period in your sentence. And it does show me here, the next thing it's going to print, line 26, your sentence from position POS, we better go look up. Position was 7. It says your sentence from position 7 to the end, a string dot substring position is this. So let's look down here. It's saying your sentence from position to the end is human to really mess things up. You need a computer. So let's see if that did it right. Position 7. Remember, we know that T is 0, 1, 2 is the space, 3, 4, 5 is error. 6 is the blank space, so 7 started the letter I. So it did print from position. So what substring does is it will, keep that from that position onward. So kind of cool how you can manipulate strings in this program. So I also want to show you an example using something like ends with or starts with. Now, each of these must have a string to work with, or don't work with characters, and they return true if a string object does or does not end or start with the specified argument, respectively. So let's head to some code so you can see that in action. So I am going to have a program that asks for my name and my phone number. I'm going to assign it to name and phone. So I am going to have them enter their name. That's going to be assigned to name. I'm going to have them enter a 10-digit phone number. So I guess I shouldn't have these parentheses. So we'll fix that in a second. Phone. So look at line 13. If the phone starts with an 800 number, remember this means or starts with an 888 number. By the way, there's now a slew of these free toll-free numbers. So I just did 2 of them, but you could have a lot more, I suspect, with lots of or statements. But here's what's going to happen. It's going to print this line if this is true. So if it starts with an 800 or an 888, it's going to say that is a toll-free number. Otherwise, it's going to say that is not a toll-free number. Now, I tried it just for once with parentheses. And of course, that's going to say that it's not a toll-free number for many reasons, including I started with a brace. So let me run it again and do a better job. So to show you what's going on here, so I'm going to type in my full name or first name. It doesn't really say on this one, right? I'll type 888-765-4321. There we go. And then when I hit enter, it says, hey, that is a toll-free number. Let me run it again and give you a legit number here. So Corinne it is. And I'm going to put in our school number, 434-832-7682. And that is not a toll-free number. So now notice something going on here. Did you notice how it uppercased my name as well? I typed in Corinne in a traditional sentence format, and then it uploaded, it changed it here to uppercase when it displayed. So I just wanted to point out we're going a couple things going on here. And it starts with, again, if these 3 digits. Now, let me now change this to ends with. So everything else is the same here. So I'll run it again. I'm going to see if the last 3 digits are 800. So I'll put 434-832-7123, 3 8s. So, yep, that is a toll-free number. Not really, but it does check to see if one of these 888s is there. Pretty cool. Now, let me kind of put all of this together in a very common way of how all of these strings and string methods are very often used. I'm importing javax.swing because I'm going to have a dialog box. Don't want you guys to forget about that. Use that once in a while in your programming. So we have string their name. We're going to have first name right now is null. Family name is now null. That means last name. And we have integer for X, no value yet. Character C, no value yet. And then we ask, here's the important part, please enter the customer's first and last name. So I've come over here. I'm pretending I'm running over here. So when I go to run it, I'm typing in my name is Sponge Bob. So I probably typed it in more like this, right? Sponge Bob. Notice I put a space between my name because just like your first and last name, we typically do. Now in memory, this is being assigned to name right here. So this is my little name box right here. So I'll just click name up here so we know what this variable is. Here we go. And it puts SpongeBob in memory. So far so good. We're now going to set x equal to 0. And let's see what this while loop is doing. Remember, a while loop, while the top is true, it'll keep going. And if the top is not true the first time, it doesn't even go in. It's not like a do while. So in this case, is 0 less than or equal to the name length? Well, the name length in this case would be 10. And here's why. 0 to 9 is 10 characters, right? So this is going to go from 0 to 10. I see a little increment down here. So it's going to go around basically from 0 to 10 times, 11 times really. And here we go. If name, this is the meat of this. So everybody look at this line. I'll slow down. If the name, now name is SpongeBob. If the character at X right now is 0. So the character at X is S. Does everybody see in the S right here? So if the character S is equal to a blank space, well, it's not. So I'm not going to do this part. I get up to 1, I come back around. Now I'm going to look at the number 1, which is the letter P. Is P equal to a space? Nope. Come back around. Now it's up to 2. Is O equal to a space? Nope. Come back around. Now it's 3. Is 3 equal to a space? No, it's an N. Come back around. Is 4 equal to the space? No, it's G. Is 5 equal to the space? No, it's E. Okay, now it just became, the incrementer just turned 6. So we come back up. It says find, in this if statement, go to the 6th item, which is this blank space. And now it's finally equal to that blank single character. Don't forget, single quotes when we're identifying a single character right here. That's why there's single quotes. Double quotes would break this. So let's see what it's finally doing. First name and family name at this point are null. There's nothing in them. So now first name is going to be assigned the name substring. That means a part of the string from 0 to whatever x is. Well, that's 6 right now. So first name is going to be assigned from 0 and the first 6 characters. 1, 2, 3, 4, 5, 6. So it's going to be assigned sponge, not the space, because it's actually doing from 0 to 5 is 6 characters. So first name is now assigned to sponge. Sorry about my capitalization. It should be all caps up here. And then family name is going to be assigned x plus 1. Okay, let's think. Right now, x is 6. 6 plus 1 is 7th. It's going to find the 7th item. So it says start at 7 and go to name.length. Name.length, if you remember, length is 10. So basically this is saying go from the 7th item, 1, 2, 3, 4, 5, 6, 7, the blank, to the end. So it's going to go to, in this case, it's going to grab the rest of it. So space Bob. So now we have this in here, or just Bob. So now we have this in here. Now look, I love this next line. This is called efficiency. This program would work without this next line, but I love it. You know what it's saying? Instead of making this program slow down and go through every other letter to look for more spaces, we're just going to set x to the length of the whole string, to 10. You know what 10 is going to do? 10 is not less than 10. So it's going to shut this sucker down. Or in this case, it would have gotten 1 bigger, 11, and definitely kicked it out. So this would shut it down. Now look at this J option pane, show message. It says, dear first name, dear sponge. \n means new line. I'm so glad that we are on a first name basis. New line. Because I'd like the opportunity, new line, talk to you about an affordable insurance protection plan for your entire, family name, Bob, family. Call A1 Family Insurance today at 1-800-555-9287. This is how they customize so many of these spam emails. So I thought this was just a perfect way to kind of put all of this together. So get started on your strings, everyone. This isn't a hard chapter, but I do find it there's so many different ways to do things that you may come up with an application that can be done more than once, and the SAM will allow you to do it any which way as long as it works. So hopefully you'll do a great job.